Afternoon, everyone, and thanks for having me here. All right. We've been doing a lot of work spatially for lots of years, and in the last 3 or 4 years we've been very focused on how we map our road corridors, how we get information about roads and move on. And it's had very much a safety focus to it. Why do we do what we do? The biggest killer of our next generations, the 5 to 29-year-olds, is actually road accidents. About 50% of the people that die from road accidents are the vulnerable users, cyclists, pedestrians, motorcyclists. About 90% of deaths occur in low and middle income countries. When you look at the cost of it, it's a hidden cost. We don't really ever tally it up. But it actually accounts for road deaths and accidents accounts for about 1.6% of the equivalent to about 1.6% of GDP, or about 10 times the global spend on roads. It's enormous. If you look at benefit cost ratios, so our NDIS has got a benefit cost ratio of about 2.2 to 1. Doing road safety work, like even fixing up lines and things like that, it has a benefit cost of about 4 to 1, and in low income countries that's getting up to about 8 to 1. So we can do some things about changing it. In recognising this, the United Nations have adopted some sustainability targets. One, to reduce road deaths by 2030 by 50%, which is a fairly optimistic target. And one of the mechanisms they're using for that is try and make sure that all roads that carry 75% of traffic or more are at least a 3-star. Now this concept of star is a concept that IRAP, International Road Assessment Program guys, developed about 10 years ago, and it's now been adopted by UN and about 100 of its member states, including Australia. Star goes from 1 is a pretty bad road, and 5 is sort of the top end of the highways. To go back to this cost bit again, the cost of fuel the cost you pay for fuel per kilometre on a 1-star road is about half the cost of road deaths and injuries on a 1-star road. By the time you get to a 2-star road, it's about equal, and by the time you get to a 3-star road, the cost of road deaths is about half of the cost of fuel. But it's a massive amount of money that goes in there. To achieve UN's target goals, they've really got to process about 15 to 20 million kilometres by 2030. Over the last 10 years, they've managed to achieve about 3 kilometres. So, big task. We've been working on some technology to help go through this, and I'll take you through that a little bit. We have an inspection system, which we call RoadViewer. It's the only one accredited in the world to use LiDAR and imagery. We're the only company in the world that's been accredited to extract features automatically or intelligently from that to fit into this road system. We'll do a quick overview of our system. So we take data in, and we take data in from whatever sources we can get access to, mainly mobile LiDAR and 360-degree imagery, but we'll also use aerial LiDAR, aerial imagery, satellite imagery, open street maps, and whatever else. There's about 60 attributes that we've got to actually identify along road systems, and they've got about 300 subcategories. So there's lots of information that goes into that as well. We have to input that data, so if we're going to basically run automated processes on it, the data's got to be good. We can't have glitches and things in it, so we have to develop techniques to make sure that what's coming through is all that we need to be. When you're looking at 1,000 kilometres of road and trying to run it, and some data's missing in that space, it doesn't help us at all. We run that then through our RoadViewer technology, which I won't go too much more into. From that, we generate a whole heap of 2D and 3D outputs, which can be where there's assets and things along the road system, and then we put it into the IRAP process, basically then star rates the road, or we generate assets, and I'll show you some examples of that. So here's some aerial LiDAR some aerial imagery that we work. We mainly use it to give us the context of the road, to be able to characterise where there's major intersections, what's near it, what's not, etc., etc. We also use aerial LiDAR, and in this case you're looking at actually a mathematically generated surface from the aerial LiDAR. That's the rate of change in slope. And if you look hard in there, you can see where all the curves and the traffic islands and the intersections and things like that are. So we can mine that in an automated way and pull that information directly out from that. Typically, or traditionally, the way that IRAP coding has been done is someone sitting in front of a video on a computer and making guesses about where the road is, where the trees are either side of it, etc., etc. And this is the sort of process they use. We use this as a final QA tool, and allows us to go back to road segments and all that sort of stuff. I won't go into that. We also use mobile LiDAR. Now this is a point cloud, a coloured point cloud. This is a section from Croatia. We actually did a project for the European Commission a couple of years ago looking at the readability of lines of roads for connected autonomous vehicles. And so that's the sort of level of detail we can get from that. We use also survey grade LiDAR. When we first started doing this, survey grade LiDAR was far too expensive to use for this sort of process. It's $350 plus a kilometre. We're now getting it down to about $60 a kilometre and pull out, and we can pull assets and all sorts of things from that. So it's becoming much more useful. We talked about doing some of the QA control. When the data comes in, we need to make sure that it's good. So we've written some programs that basically, this is data straight out of a feed of a 3-coloured point cloud. From that we're pulling out first the road itself, then the road features, road surface features, and then line markings, etc., etc. That's processing at about 400 kilometres an hour on a single computer. So it's a really fast process, so we can get data through and check it really rapidly. We then, once we've made sure that the data is complete and it's all going to work, we'll run it through one of our automated processes to pull out all the features. And at the top, I won't read them all out, but they're the attributes that we're pulling out from that road system in that space running through it. They're about 3/4 of the attributes we need for IRAP coding to go through. So this allows us to, in terms of one, the attributes for IRAP coding, but also in terms of road assets. We can work out where the power poles are, where safety barriers stop and start, where there's medians, how wide the shoulder is, etc., etc. So you can come back and then have all that information going forward. The other thing we do when we're working on, on the left-hand side is a 360-degree image, or part of a 360-degree image. On the right-hand side is coloured point cloud, but it's not just coloured point cloud. We've taken the coloured point cloud and the photo imagery, and we've enhanced the coloured point cloud with the imagery to fill out the whole road corridor. Now, we're getting this down to about 10% of the original input data that we're getting. We're getting it down to where we can actually have this in something like Google Street View, where you can actually jump in and look at things, but not just jump in and look. You can actually measure all that because it's all accurate survey points going through it. So you can stop it, go through, work out widths, those sorts of things in that space. Out of all that data, most of our clients don't want the whole density of all the information that's there. So we basically can generate a heap of shape files into that space. And basically that then gives them where all the assets are and all the information they need to work from going through. So we effectively take terabytes of data and give it back in less than megabytes. Final uses, or the uses other than the road safety component of all this, for that data once we've gone through and captured it all. And there's a whole list through there which I won't go through in great detail, but you can see that we do things like for heavy vehicle analysis, we're moving wind turbines, 80-metre long wind turbines. We'll put that into that same data set and we'll drive a truck through the whole thing virtually. We'll work out where all the clash points are, what needs to be removed, what route the truck could take, etc., etc. Same with bridge clearances. We did some projects in the US where there was bridges that hadn't been measured for years because they couldn't stop the traffic long enough to go through because it was too busy. But we can drive through with mobile LiDAR and pull that sort of information out. Yeah. I think I'll stop at that point and I'll let the questions.
Any questions?
Yeah.
Does your system with your LiDAR also look at road surface and damage to road surface and those sort of things?
It's the system. We basically get data from people, and road surface and damaged road surface could be the data we put in. They are using LiDAR to scan all that and run through the process. It's not something that we've used in this so far because it's a bit too cost prohibitive, but it's definitely most of the councils and DOTs we work with have some form of information like that. And so when we're looking at things like speed resistance, we can jump into that data and find out what's going on, or road condition. Yes?
You just sort of answered it a little bit, but I was wondering if you had much uptake from local governments for this rapid data capture.
It's an emerging market. It's slow. What we're really pushing hard is that the amount of other information you can get for this from this data. So the road safety component itself, typically all they get is an Excel spreadsheet that says this 100 metres is a 1, 2, 3, 4, 5. They've done all that analysis that you talk about and you get a number at the end of it. What we give them is shape files, is 3D images, with all that information that you can pull out. We've done a couple of pilot studies. We did one for Victorian roads. We're doing one, we've done one in Western Australia before, we've done some work for New South Wales, Transport for New South Wales. They're starting to adopt it, and we're hoping they'll adopt it very fast.
Thank you very much. In the interest of getting